Thanks, Richard, for the introduction. My name is Cheyenne Sanyal. I'm head of marketing and strategy at a company called BlueWan. We're based in, we have our R&D facilities based in Paris, France, and our commercial global facilities in London. So I want to thank Steve Yablonsky and Richard and team for hosting us this week. So I'm here to talk to you today about a wireless system that's supposed to deliver the equivalent of fiber optics, broadband. You hear a lot, we've heard a lot today about the data demand needs and the increasing thirst for data worldwide. Some of the solutions that we've heard about in terms of backhaul and in terms of bandwidth providing is fiber-based, but we all know that that's a challenge in certain areas, so whether it's rural or whether it's emerging markets or landlocked environments, that you can't deliver fiber to the home or fiber to the premises. So at BlueWan, we developed a technology to deliver fiber equivalent services wirelessly, and I want to talk to you a bit more about the technology itself versus turning it into a PR presentation, which is not what this is about. Just a couple of things. BlueWan came from the aerospace and defense industry. We were affiliated with Thales Communications, and our founder was the then Chief Technology Officer for Thales Communications. And in 2005, we were spinned off to address the carrier market as opposed to the defense market, which is where Thales usually specializes in. Along the way, we signed a couple of super fast broadband trials, notably with municipalities like the city of Paris, but also with companies like carriers like Orange in Europe. And we launched commercially in 2011, just a few months ago, at Mobile World Congress in Barcelona. In the last few months, we've actually gotten a lot of industry recognition on our solutions, essentially because we're taking a different tack on what bandwidth means. Rather than looking at small chunks of spectrum like 20 megahertz or 10 megahertz like we were hearing before on the long-term evolution type spectrum, we're looking at very wideband solutions with the belief and the strong core belief that in order to deliver ubiquitous next generation access, spectrum is going to be king. Spectrum is king, of course, in mobile, but spectrum is king in any wireless system. The more spectrum you can get, the more you can leverage, the faster bandwidth you're going to be able to deliver. It's a simple equation. So to that effect, our technology has received a couple of industry awards. Mobile Broadband Innovation of the Year from Frost & Sullivan. We just found out last week that we're finalists for Best Mobile Product from Light Reading. And part of this is because of the approach that we're taking. Now with Globecomm, we got introduced to Globecomm about four and a half months ago. And we are a manufacturer of equipment. But at the end of the day, the systems that you deploy, the services that you want to deploy on top of that kind of infrastructure are quite advanced and complex. You need to deliver content, you need to deliver voice, you need to deliver hosted solutions, and you need to do that in a very quick time to market, low OpEx, low CapEx. So the combined value of working with Globecomm for BlueWan is we bring some innovative technology, but Globecomm integrates it and adds their value-added services to their market and segments. And together we deliver high bandwidth solutions. I think we've all seen various charts and statistics about bandwidth growth, so I'm not going to spend too much time on that, but I think we all recognize that IP traffic is growing exponentially. We talk about hockey stick growth curves, and I think that it's a pretty self-explanatory slide. But at the same time as this demand increases, the digital divide is deepening. In the UK, for example, BT made an announcement a few days ago that they're testing now 300 megabits per second fiber optic services. Now, that's great, but those 300 megabits per second are not going to be rolled out in rural. They're going to be rolled out in areas that already have 100 megabits per second FTTH, fiber to the home type services. So, although this is great from a technological perspective, in terms of providing ubiquitous bandwidth across a given area, it's not going to be a problem solver. In the UK, a third of UK households, for example, don't have access to broadband, and by broadband I'm defining superior to 1 megabits per second, right? In France, 19 million or nearly 20 million households don't have access to 1 meg broadband. The average connection speed in the US currently, I believe, is around 4 meg. So there's a problem in terms of how do we increase that bandwidth given the previous slide that we saw where the demand for bandwidth is increasing. This is an example, for example, in the UK, where the cost of deploying fiber to the home using, say, the more cost-effective GPON technology is roughly around £26 billion to cover 100% of the UK population. Now, to put this into context, the actual budget that the UK government has from a broadband policy perspective is roughly around £800 million. And then to add a bit of flavor to that, British Telecom, which is the incumbent and historical operator in the UK, is investing around £2.6 billion in fiber optic broadband in the UK. But that's only going to cover, according to their numbers, around 2/3 of the population. So there's a big challenge between the objectives, whether that's the UK, the European Union, the Obama administration, or various other administrations, between the objectives to provide ubiquitous broadband and the ability to deliver on that broadband. And that's really where we come in. So if you want to talk about fiber radio or combinations of hybrid networks where you're having high capacity fiber in one location and trying to constellate that fiber capacity to other areas, you got to look at your spectrum options. To deliver the end consumer services that you're looking at from a fixed perspective, which is typically the triple play service or the multiple play service, well, you need high capacity networks, especially if you're looking at use cases around HDTV, 3D TV, or interactive television, over-the-top services, voice over IP, gaming, etc. And I think a couple of other use cases that we saw that I think you introduced around telemedicine or teleeducation. And beachfront spectrum, which is the spectrum that we'd say is around under 3.5 gigahertz, and it's called beachfront spectrum because it's this highly valuable spectrum that propagates very nicely, doesn't require any pointing a dish at anything, and can be used in mobile broadband. That spectrum is one, very expensive, as we've seen, and two, doesn't necessarily have a lot of capacity. So if you want to deliver those kinds of services to the home, you need to start thinking about how much more spectrum you can have access to. So we looked at it and said, okay, well, you're going to have to look at spectrum beyond the beachfront, right? So you're going to have to look at microwave, potentially. So we looked at 12 gigahertz, for example. We looked at 40 gigahertz, and we saw that there was large amounts of contiguous spectrum available in those frequencies. In the 12 gigahertz, we're talking about, give or take, 1 to 2 gigahertz wideband spectrum. And in the 40 gig, in most countries, we're talking about 3 gigahertz of spectrum available. So that's a total sort of access to around 5 gigahertz of spectrum. So I know that doesn't mean a lot out of context, but if you think about it, in the previous presentation we were talking about spectrum allocations in lots of 10 or 20 megahertz. And here we're talking about spectrum allocations in lots of 1,000 to 2,000 megahertz. And that enables different kinds of use cases. Not necessarily mobile use cases, but definitely different kinds of broadband wireless access use cases. In terms of regulation around those frequencies, it's work in progress. There are some countries that have started to allocate 40 gigahertz spectrum on a technology and service neutral basis. The UK is one of them. So Ofcom in 2007 allocated around 2 gigahertz of spectrum, 3 gigahertz of spectrum total. One operator was able to obtain 2/3 of that spectrum. To give you an idea, they obtained 2 gigahertz of spectrum for roughly $150,000. 15 years, nationwide, non-revocable, $150,000. In comparison, they had to spend around $20 million or $30 million for 3.5 gigahertz spectrum, around a 20 megahertz allocation. Different use cases. Now, part of it is because this is not beachfront spectrum. So the real estate is less expensive. So based on that, we developed a solution that would have 2 applications on a single architecture. One is a backhaul solution targeted at small cells. So I think we heard Ed talk about small cells and small cell networks for the mobile broadband LTE deployments in the future. And one of the key challenges about small cells is how do you bring bandwidth to those small cells in your wireless network? You have a lot more cells than you used to, sometimes 2 times or 3 times what you have today, especially in a metro urban environment. But your ability to pull fiber to those sites is limited by time, limited by budget, and limited by administration and overheads, way leaves and stuff like that. So you look at microwave as an option to backhaul those small cells. But the problem is that most of the operators have to pay rental agreements on installing dishes to backhaul those cells. And in the US, that can cost $700 per dish per month. In the UK, it's slightly more cost effective. It's around $2,000 per dish per year. But ultimately, if you see the cells becoming ever denser, you're going to have to provide more dishes on the hubs. That's more rental costs. And you're pretty soon hitting a brick wall in terms of how quickly you can backhaul those small cells. So that's one angle that we're looking at. The second is on the broadband access. And that's the fiber through the air access solution, which is really a fiber optic complement. And what we aim to do with this solution is deliver or enable operators to deliver 100 megabits per second per home. And along with that, integrate IPTV services, voice over IP services, side-loaded video to enable a very quick time to market for a triple play solution. To give a comparison of this, the best way is to look at what we know. So let's take a look at a WiMAX sector. A WiMAX sector on a good day generates around 35 megabits per second sector throughput. And that's on a really good day at very high levels of modulation. Now, using FTTA, a radio about the size of this generates 2.5 gigabits per second throughput. Now, that changes a lot what you can do on a sector. Because let's take a very basic use case of half a meg committed. Right? This is minimum basic service, half a meg. And if you had that kind of committed information rate, you could enable roughly around 280 simultaneous connections on that hub. With FTTA, this is assuming a 4-sector deployment. With FTTA, you're looking at over 12,000 customers on that hub. And that's using half a meg. But we're not here to talk about delivering half a meg. What we really want to be able to do is not deliver service to 12,000 customers on a sector, but deliver 100 megabits per second. But the only way you can do that is if you have starting point capacity in hand. So how we do it is, like I said, a 1 gigahertz wideband radio. And that creates a sector using a small antenna. It kind of connects like so. And then generates 2 gig on a sector. And then what happens is you install a small dish on top of your home that draws a cable, connects to a modem, and delivers the bandwidth. So to give you an example of what that looks like in real life, we are installed at the entrance of the Globecomm just in the lobby. And you'll see what the transmission hub looks like. You can also just go outside and see what the transmitter looks like and what the CPE looks like, and also see the live network in demonstration to test the services. But one of the key things is that we're able to enable multiple use cases, including VoIP, IPTV, high-def OTT services, as well as high-speed broadband. And how we do that technologically is we use standard modems available in the market, and we aggregate these modems together to create a 1 gigahertz wide pipe. So we take lots of small pipes and bond them together wirelessly to create a big pipe. And that's basically how we try and replace the FTTX or complement the FTTX architecture. With Globecomm, we're looking at adding some value-added services to this infrastructure. So for example, on a project that we're working on in the Bahamas, the plan is to actually host a lot of the video locally in the Bahamas and not have to go through the core network, core internet, to distribute high-end video, but have that content locally hosted. But you still need to have a system that's wide enough to deliver simultaneous streams over the network. Voice over IP, same thing, using Globecomm's expertise to deliver that as a hosted solution to the operator. This is kind of like what it looks like in the field. You have the fiber connectivity to a high point. You create a 90-degree sector, and within that sector you can basically provide bandwidth to residential services, businesses, but also 3G or 4G cell sites. And where you drop off bandwidth, you can also extend the reach of that bandwidth by using a drop-off point as a relay. So it's a point-to-multipoint architecture. And the average range in the 12 gigahertz frame is around 12 kilometers. And in the 40 gigahertz, closer to 1.52 kilometers. Architecturally, this is kind of what it looks like. This is what we've got set up outside. We've got a satellite feed. We got well, in this case, we have an over-the-top feed, IPTV server, the fiber connectivity. It gets multiplexed into a product that we have that essentially muxes all this information together, transmits it to a radio, gets captured by a CPE, and then downloaded to the Blue WAN box. A couple of examples of our 12 gigahertz equipment.